Hey everyone, welcome back to my channel. In this video, I'm gonna walk you through all the models in your social media project. These models are the backbone of our entire backend. They define how our data is structured and stored inside MongoDB. Right now, I'm inside the main folder directory, and within that, we have a models folder. So we have a backend and we have a models folder. I have already written all the code to save us some time, so we can focus purely on understanding how everything works. Inside this folder, each of we have we have got four main models: the user model, the post model, comment model, and the message model. Each of them handles a specific part of the app. User manage authentication and profiles, post handles media and caption, comments connect users to post, and messages take care of our real-time chat features. So let's go one by one and break down how each model works and how they are connected to each other. So let's start with the user model. So I open it because honestly, the user is everything in our app. Every post, every comment, every message, it all connects back to a user. So, so right, and this is the user model.js folder. At the top, you can see at the top we import Mongoose from Mongoose library. Mongoose is an ODM, which means Object Data Modeling Library, that MongoDB provides to make it easier to define schemas and interact with our database. Basically, it lets us structure and organize our data like objects instead of raw JSON. Next, we create our user schema. This is our user schema using the Mongoose schema method. This method takes two arguments. The first one defined the structure. The first one define the structure of our data, and the second one handles configuration option. The second one handle configuration option, but here we have set timestamps true, which automatically adds create add and update add fields to every document, so we don't have to do that manually. Now inside our schema we define all the fields we need. The first one is clerk ID, which we get directly from Clerk authentication system. This ID is unique for every user and comes from the Clerk SDK after they sign off or login. Then we have email, full name, username, profile image. These values are also fetched from Clerk, depending on which OAuth provider the user use, like Google or GitHub or any other. It's depend on the way you want to show them. Then we have got field like bio and cover image. So here I'm not using. You can use it and you can't fetch on front end. But yeah, because bio and cover image, it's obvious for social media app, but I'm not using it. But I just want to keep it so you can use my code. So, and next are the social part: followers, and following. Both are arrays that store the ID of other users. So if you follow someone, their ID goes into your following array. And if someone follows you, their ID goes into your follower field. Pretty similar to how Instagram handles it. You also have like post, save post, upload post. This field help us track user activity, what post they have liked, what they have saved, and what they have uploaded. This makes it easy to show personalized data on the front end, like a user's favorite post or uploads without running heavy queries. And finally at the bottom we export the model. So this line registers the model inside Mongoose and create a corresponding collection in MongoDB, which will be automatically pluralized as users. You can see user on MongoDB collection, you can see users. So it's gonna be plural. Once exported, we can import and use this model anywhere in your backend logic like controller or routes. And that's our user model, clean, structured, and ready to scale. Alright, now let's move on to our post model, because this one powers the entire social side of our app. Every photo, every video, every caption a user shares, it all lives here. So I'm gonna open it up, and here you go. So this is the post.model.jx file. Just like before, at the very top we import Mongoose library. Then we create our post schema using new Mongoose schema. Schema is a method. We pass in two arguments. This is the first argument. The first defines the structure of the document, and the second handles configuration option like timestamps. We already discussed before, right? Inside our schema, the first field is user, which is a reference field. Type is mongoose.schema types.object_id, and reference users require true. So whenever we query a post, we can easily populate user details like their username, profile image, whatever it is. The next is a media field. This one's an array because a post might include multiple files. For example, multiple images or even a video. Each media object includes a URL, which is a string, and a type, which can be either image or video, enforcing using an enum. That way our backend knows what kind of file it's dealing with. Then we have caption, just a string field with an empty default value. And tags, which is an array, so user can attach multiple tags to a single post. After that, we define the likes, the comments. These are arrays. Both store objects ID. Both store object ID. You can see, and which are referencing the users, and also here document that belong to this post. So if the post has 500 likes, those user IDs will be stored right here. Finally, we add a few cache counter, likes count, and we have also viewed by field. Right, we also have viewed by field, which tracks which users have seen this post. That helps us keep count of unique viewers, kind of like what you see on YouTube or Instagram inside. The view field is just a simple number, right? And then finally we add a few cache counters, likes count and comment counts. These are optional but useful if you want faster reads. Instead of recalculating likes or comments every time you fetch a post, you can just increment these numbers as changes happen. At the end, we set timestamps true to automatically handle create at and update at, and then export our model like this. So yeah, that's it. A clean scalable post model that connects directly with your user comment models and is ready to support likes, views, comments and tags just like a real social media app. Now let's go over the comment model. At the top, same as before, we import mongoose. Then we create our comment schema using mongoose.schema. Remember, the first argument defines how you want to structure our data, and the second one is for configuration option. Inside the schema, we have got a few important fields. First one is text. This is where the actual comment content is stored. Type is string and it's required. And we have also trim max length 1000. So you can put as you want. The second field is user. This field tracks who made the comment. It's an object ID that reference the user model. The next one is post. This connects the comment to the post it belongs to. Again, it's an object ID referencing the post model. Then parent comment field. This is for replies. It's a self-referencing, which means a comment can point to another comment. If it's top level comment, this field just stays null. So you can see. And then likes. This is an array that stores the users who like that particular comment. And then we have likes count and replies count. Both are numbers defaulting to 0, and they make it faster to fetch counts without recalculating every time. And finally we add timestamps, and then we export it using mongoose.model comment schema, right? So yeah, now let's look at our last model, the message model. So let's open up. Just like before, we start by importing mongoose and then define our message schema. Remember, the first argument is how we structure our data, and the second one is for configuration. Inside the schema, we define first sender ID. This is a field, sender ID field. This field stores the ID of the user who sent the message. Its type is object ID, and it references the user model. And required is true. And then second one is a receiver ID. This one tracks who received the message, same type and reference. So sender ID is who sent it, and receiver ID is who got it. And the next field is text. This field holds the message content, and the type is string. And then the next one is media field. This is an array. Because we allow users to send images or videos inside that array. we store objects. We store object with, like we store our object with URL field and a type field. The type field use enum to make sure users can only send either an image or a video. And finally, we add timestamps. So MongoDB automatically tracks when each message was created and updated. And one small difference here, instead of defining and exporting the model in online, we first create like this, right? And const message and mongoose model, and then we export it below using export default message, right? There is no difference, but yeah, this way also people like to do it, and so that's what I did. And that's it, all our models are done. Now we are ready to move on and start building the controllers where we will handle the logic behind creating, updating and fetching all this data.